Welcome to episode 4, which is a continuation from episode 3. But basically, we're dealing with questions here, and then we'll continue with content when we finish dealing with questions. And we said these are basic questions that we want everybody to quickly get a hang of. All right. Initially, 1,2 moles of CS2 gas and 4 moles of chlorine gas are injected into a 2 dm cube container. Very important. Initially, 1,2 moles and 4 moles initially. Analysis of this equilibrium mixture shows that 138.6 grams, now we're talking about grams, of chloromethane, all right, is present. Calculate the equilibrium constant Kc at this temperature. All right, look, basically, let's fix this whole situation with our table. All right, good. I do have my table, and if you remember, we said what we have chemicals here, we have ratio, we have initial number of moles, we have change in number of moles, we have equilibrium, number of moles, and concentration, which is number of moles divided by volume, and then the volume figure there. All right, so if I go back, my volume is 2D. Okay, let's start from CS2, 3Cl2. All right, so we have CS2, we have Cl2, and this is 1, this is 3. I'm sure you know where the numbers are popping out from. All right, and then we have S2Cl2 and CCl4, which is 1 mole, 1 mole. S2Cl2 and CCl4. All right, initially we were told that 1,2 moles of CS2 and 4 moles of chlorine gas. All right, 1,2 moles and 4 moles are present in a 2 dm cube container. Do you remember now that we do not have the product? So it's quite easy to work with now. 0 and 0 there. Okay, at equilibrium, it is found that 138.6 grams of CCl4 at equilibrium, 138.6. And now, guys, you cannot write the 138.6 in here. Do you know why? Because this table is dedicated with a number of moles, right? So we cannot write that in here. What we need to do is you need to do your calculation. All right, if you do your table a bit big, all right, you can do your calculations in the table, or otherwise you do your calculation on the side. But please show this particular calculation. All right, number of moles of what compound again? This calculation ends marks, so you need to show it. All right, CCl4, 138.6. All right, CCl4 is mass over molar mass. So 138.6, that's the mass. What is the molar mass? You go to your periodic table. All right, carbon is 12 and chlorine is 35.5. You get that from the periodic table, so we can do our calculation quickly. Please remember, I am repeating, this calculation must be shown. All right, 138.6 divided by carbon is what? 12 plus I have 35.5 multiplied by 4. I hope that makes sense to us. And we have 0.9. All right, let me put this value there. Here I said 12 plus 35.5 times 4. Very key. Now this is at what? Equilibrium. So there's 2 marks there already. At equilibrium, 0.9 of CCl4, equilibrium, 0.9. I hope it makes sense now. If you followed the videos, what I need to do, I know this is going to be a plus, a minus, and a minus. You know why, right? So what will this be here? 0 plus a particular value would give me 0.9. Now, guys, we are smart now. Look, it's rise and chicken, ratio and change. 1 is to 0.9. This 1 again, I'm just going to copy it now. All right, so if you follow the videos, you will understand why I'm just copying. 1 again is 0.9. Makes sense? All right, I don't know this. All right, we said B. You can simply cross multiply. B times 1 will be B, And 0,9 times 3 would give you what? 2,7. I hope that makes sense. 2,7. Such that if you were to divide this change by the smallest number is 0,9. 0,9 divided by this 0,9 would give me 1. 2,7 divided by 0,9 would give me 3. 0,9 divided by 0,9 would give me 1. And that. So that's the ratio. Now we add 1 minus 2. 1,2 minus 0,9 would give me 0,3. 4 minus 2,7 would give me 1,3. 0 plus 0,9 would give me 0,9. All right. Now we can work out the volume, which is what? 0,3 divided by 2, and that is 0,15. 1,3 divided by 2 would give me 0,65. All right. 0,9 divided by 2 would give me 0,45. And 0,9 divided by 2 again would give me 0,45. All right. So my table is set. Now I need to write my Kc expression. I'm sure you remember how to do that, right? So my Kc expression, therefore, will be the concentration of it's S2, it's S2Cl2. All right. S2Cl2, that's a 1 there. CCl4, it's also 1 over, what do we have here? CS2, which is 1. And we have Cl2, chlorine gas, and that is 3. So what do? Substitute. Okay. Guys, these activities are still basic activities. We are going to go increase the difficulty level of these activities just in a while. We have 0,15 there and 0,65. Oops, sorry. All right. My reactant CS2 is that 0,15. By the way, and 0,65, but this one is having an exponent there. Okay. Now, what else do we have? S2, Cl2, 0,45 there. What's the power one? And CCl4, 0,45. So what is your final answer? Pull out my calculator and work through. All right, so 0,45, close my bracket. 0,45 again. Is it 0,45, guys? I think I'm making a mistake somewhere. Oh yeah, it's 0,45. All right. Where's my calculator? All right, we close the bracket there. And then the denominator, we have 0,15. I close the bracket and I have 0,65. And that is to the power 3. And my answer is 4,92. Remember, no unit. I hope that is okay with everyone. Spent about 8 minutes to do that question. See, I'm cutting time as I go on. The next one. All right. When a number of moles, yes, now we are making it a bit more hectic. When a number of moles of X2 and Y2 are placed in an empty, closed, remember it's closed, and it's empty, closed, empty, closed system, empty, containing a container at 800 degrees Celsius. A reaction takes place and eventually reaches equilibrium according to the following equation. So we have X2, 3Y2, and 2XY3. At equilibrium, there is 0.4 moles per dm cube of Y2 and XY3. At equilibrium, there is 0.4 moles of Y2 and XY3 present. You are also given information for the reaction. All right, we have this. Okay, we have a table. All right, which means at 400, the Kc is 0.8, at 6. Remember, I did mention in video number 3 Is it video number 3 or video number 2? That the only factor that changes is 3. The only factor that changes Kc value is temperature. So as temperature changes, Kc also changes. I'm not saying it's increasing, guys. We are going to deal with that concept as we go on. Calculate the initial moles. Calculate the initial number of moles of X2 and Y2 placed in the container. Now, this, we said we're going to increase the difficulty level. We just did. When the number of moles, X2 and XY, which means we do not know the number of moles of X2 and we do not know the number of moles of XY. We don't know. We just know they are placed in a container. All right. A reaction. Okay, so we have, basically we have 3. Let's quickly draw our table. I think that's where we should start from. Let's get our table. Okay, I do have a table. I'm not going to need the side. So let me just delete that. All right, so what do I have here? I have my chemicals. I have my, you don't have to write chemicals. No, it's not, it's just, I like to write it because I'm teaching. All right. Okay, let's go fill up together. We have X2, we have Y2, which is 3, X2, Y2, and XY3. Don't forget, it's 1, 3, 2. X2, Y2, XY3. X2, Y2, XY3. And it's 1, 3, 2. Okay. All right. What do we know? We know that we do not have this value, the initial. They said a number of moles. Okay. So can we write it as X and Y? Unknown. Okay. And it's an empty container, so we have 0 there. Okay. Just take it one step at a time. At equilibrium, all right, at equilibrium, there is 0.4 moles per dm cube. I love this question. You don't just throw the values. Moles per dm cube talks about what? Concentration. So the concentration here of Y2 is 0.4 and XY3 is 0.4. Mind you, concentration of Y2 and XY3. All right. So when I want to fill this, where do I put my 0.4? Under equilibrium, but not number of moles. It is concentration of Y2 0.4 and XY3 0.4. I hope it makes sense. All right. By the way, what is my volume? My volume is 2. Look, let's see what we can get out from here. I want you to watch this. Now I am working up here. Do you remember that C equals to N over V? From here, what's my concentration? 0.4. What's my volume? 2. Cross multiply, N is 0.8. I hope that makes sense. I'm working up the table. So if I were to divide 0.8 by 2, I'll get 0.4. This value would also give me the same thing. Does that make sense? Beautiful. All right. Now this is from 0 to 0.8. It is therefore increasing while these two are decreasing. Now what value would I have here? I'm going to have 0.8. Okay. Now let's put a B here and an A here. Can we cross multiply? 2 times B would give me what? 2B. Please show calculations. Please show your calculations. All right, so 2B equals to 2,4 because I've cross multiplied. Do you know where my 2,4 is coming from? 2 times B, 2B, 3 times 0,8. Please don't forget it is ratio and change. All right, so what is B? Divide both sides. That will give me 1,2. Okay, is that fine? Now, what about the side? This is 1 and 2, or you can even use this one. 1 times this would give me 1,2, right? So 3 times A would give me what? 3A equals to 1 times that would give me 1,2. So what is A? A would simply be 0,4. All right, and if you understand maths very well, you would see that it's ratios. All right. Look, let me show you something else, something beautiful here, so you understand what the ratio is all about. 1, what would you do to 1 to get 3? You multiply by 3, right? Check this. 1 times 3 would give me 3. Come down here. 0,4 times 3, 1,2. How would you get 2 from 1? 1 times 2 would give me 2. What is 0,4 times 2? 0,8. So there are so many ways of getting these things done. All right. However, I don't know this, but I can solve this. Oh, by the way, I wrote y here, right? And I wrote x here. Let's solve this. Look at this line. Y, there's a minus there. Minus 1,2 equals to what? 0,8. Do you see I have my y already? Move that over. 0,8 plus 1,2 would give me what? 2. It means my original value here is 2 moles. All right. Now that's simple. But there is nothing here in the first column, so I've got a problem. Now I've got to find a way out. X minus 0,4, guys, is still x minus 0,4. So x minus 0,4. Because I have nothing to fill there. What is my concentration? The number I have there divided by what? 2. That's all I can do, guys. There's nothing more. All right. But I am given, let's write the KC expression. It's xy3 over, I'm sure you know where I got all those values from now, my expression, and there's a 3 there. It's 1, 3, 2. Let me do this. All right, then I go to my table. Okay. You can pick any of the values. We would get the same answer. All right. We would get any of the values. All right. So let's just pick the first one. At 400, I have 0,8. KC value is 0,8. So I'm going to substitute there. What is xy3? Concentration is 0,4. All right. So this is what? 0,4 squared over, I do not know this, guys. I want to leave it like that. And what is the hydrogen? Hydrogen is also what? 0,4. It's the one with the cube. Okay, let's do some maths now quickly. I don't know how you want to do your maths, but let me make it simple for everyone. Cross multiply. Let's try to make it simple for everyone. All right. And if I do the maths, I'm sure you can do the maths here, x2, which is basically dividing both sides by what's on the left. All right, so you have 0,4 squared. Okay, over 0,4. I keep missing the dot. 0,4. Need to delete that and put a 3 there. Multiplied by 0,8. I'm sure you know your maths. All right. Okay. So what do I have? I have 3,125. But that is the concentration. Now let's go check. What is the concentration of X2? X minus 0,4. This is what I got. X minus 0,4 over 2. So what do? I'm going to cross multiply and do the addition, right? Good. Multiplied by 2. Now remember the 0,4 goes to the right. It becomes what? Plus 6,65. And it is moles. We got moles. X was in mole. And that's your question there, guys. You would see this is a bit lengthy. It's 9 marks there. All right. Calculate the initial number of moles of X2. All right. So I'm going to ask you to please rewind and work through together again. All right. I have one more question, and I have about 6 minutes. Let's see if I can run through. All right. 0.5 moles of hydrogen gas and 0.5 moles of oxygen gas is sealed in 200 cm cube. Issue there. All right, at a temperature of 118 degrees Celsius. The following chemical equilibrium is established after a certain time. All right, so we have that equation there. Analysis of the equilibrium mixture shows that the mass of oxygen, again they're using the word mass, the mass of oxygen is 9.6 grams. All right, 9.6. Calculate the equilibrium constant. We want Kc. Basically, I need my table. So let's run quickly and get the table done. All right, we do have 3. So I don't need this. Okay. Don't cancel. Remember, I can electronically deal with that. And what do I have? I have my ratio. I have my initial number of moles. I have my change in number of moles. I have my equilibrium in number of moles, and I have concentration, number of moles divided by volume. All right, we have chemicals here, like we said, and like I said, it's not really so crucial to have that. Hydrogen, oxygen, and water. All right, hydrogen, oxygen, and water, and it's 212. Hydrogen gas, oxygen, and water. I'm sure you understand where my 212 emanated from. All right, so 0.5 moles of hydrogen gas and 0.5 moles of oxygen are sealed in a 200 cm cube. So initially 0.5. All right, this is 0 again in this case. I'm going to look for a question where that is not 0. All right, volume is 200 cm cube. What do? We divide by what? 1,000, and that gives me 0.2 dm. Please show every calculation you do. All right, 0.2 dm cube. Okay, what do we know again? Analysis shows that the mass of oxygen is 9.6. All right, oxygen, which is this, 9.6 grams. Okay, what do we know? Number of moles of oxygen gas is mass over molar mass. So the number of moles, we have 9.6. Oxygen is 16 if you go to your table. 16 times 2 would give us what? 32. So what's the number of moles here? 9.6 divided by 32. And that gives us 0.3. At equilibrium of oxygen. Okay, I'm glad here we have that. Look at this. You started with 0.5, you're ending with 0.3. What's happening? It's decreasing, we're losing. Good. And what am I losing? Okay, I want to do every tiny detailed calculation. 0.5 minus x equals to 0.3. Minus x equals to 0.3 minus 0.5 minus x equals to minus 0.2. X is what? So I'm losing 0.2 moles. Can I work with my ratio now? Again, look, this one is very simple. For you to remember ratio and change. For you to move from this 1 to this 2, what do? You multiply it by what? 2. So come here and multiply 0.3 by 2 as well. You get 0.4. But if you don't want to do it that way, you want to stick to what we've been doing, put an A there. 1 times A. 2 times 0.2. I hope it makes sense. So what's happening? This is what? Increasing. So 0 plus that will give me 0.4. By the way, this is another 2. I have 2 here. I have 2 there. It's 0.4 there. It has to be 0.4. Decreasing again because it's a reactant. So what do I have? 0.1. So what am I going to have here? 0.1 divided by 0.2, which is equal to what? 0.5, because it's just half. But you can check on your calculator if you are not sure. All right. And what do I have here? 0.3 divided by 0.2. This will give me 1.5. And I have 0.4 divided by 0.2. That will simply give me what? 2. What do I need now? I need my Kc expression. Remember, my product is water. So Kc equals to the concentration of water over hydrogen and oxygen. And I remember my hydrogen must have a 2 because it's 2 moles there. All right, can I put my values? It's 2, 1,5, and 0,5. 2 squared. Hydrogen is, I don't want to get it wrong, 0,5. And oxygen is 1,5. And that's Kc there. Okay, so now, guys, our next set of questions will be a bit tricky and on a higher level. But generally, the principles that we need to learn are the things that we have taught. All right. Every other thing is just going to be manipulations. 10,7. Kc is 10,67. All right. So we will look at a few more activities and delve into some other concepts. But I think we'll delve into some other concepts first and continue with more activities and full questions now. So quickly, we're going to go into the next video and deal with Le Chatelier's principle and work out a few more concepts. Then go through full questions and they will be able to look at high order Kc calculations. So go through, I think it's about 6 or 7 calculations that you have now. Get the basics first. Okay. Catch you in the next video. Goodbye.